to relax it. We'll be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too late. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another day at 100 days of Rootkit. If you are joining us once again, thank you so much for joining us. If you are coming back, or if you're new, thank you for joining us. All right, thank you for joining us either way. You guys are super awesome. Let's go ahead and get switched over to our more chill music here and get a little situated, moved along. All right, let me pull up my little blurbish stuff. We're going through 100 Days of Rootkit, where we're teaching you guys for 100 days straight how to get our Comp Sci Cert, which is a complete replacement to a college degree. Also, while we're doing this, we're doing some fun things like giveaways. If you go over to our site, you can go to the blog section, and on there you'll see week 4. If you go there, you can enter the giveaway and win yourself some merch. This week we're giving away all the stickers that we have, all a lot of them, 8 of them plus, or 9, 10 of them, plus the exclusive Discord sticker that you cannot get anywhere else except very exclusive events. We do not sell or give these out very lightly. Also, if you are enjoying the stream and you want to help us out, we are a non-profit registered here in the US of A. If you go over to our Streamlabs charity link, which I will post into the description, or not the description, into the chat for both of these, because the description links have always been messed up because of this streaming application. Here, you guys can donate. All donations are being matched 1 for 1. You can also get epic merch, like our super epic collab t-shirt, which I put somewhere that I don't remember, and this amazing sweater. Look at this sweater. And we got the Rootkit logo on the back. It's so cool. It's so warm. It's my default shirt now, moving forward, ever since we got it on stream. All right. This one is special to my heart. Also, as we hit certain types of monetary benchmarks here, you'll see we have goals. Like, well, I'm going to teach for 24 hours straight, or I'll just shave my head off here live on stream. And the one we're not going to get to, because it would just be really weird, which would be shaving my beard. Oh, in the last one, I haven't really showed this one on because we really don't want this one. We're getting a tattoo of the Rootkit logo. For you guys don't know, I absolutely hate needles. All right, every time I have to go get vaccinated, it's not a pretty sight. Right? I act like a 2-year-old. Right? I start screaming my head off. It's not good. It's not good for anyone. Some people here that are that have joined us have seen me when I've had to go get my shots. It's not good. I was in the military for several years, and you get lots of vaccines when you're in the military, and they didn't like me very much. Let's just say that. All right. Let us see. If you want to follow along, if you go over to our GitHub page, you can see our Comp Sci Cert there, and you can follow along there. We have everything listed that you need to know in order to get the cert. In order to pass, it's all listed here. All right. So we're going to go over to networking protocols because that's where we are right now, and we're going to continue on forward. Are there any questions, comments, or concerns from the people in the chat from our previous days, or that you may have now that you're joining us and you're new? Go ahead and drop that in the chat. We're going to continue chugging forward. I'll be answering questions as needed. Also, if you are a Patreon or Discord member, thank you. But you can become one. All right, and if you are, you can join me. I'm in the events voice chat in Discord. You can hop in there and ask questions as you see fit, willingly. All right, you don't need to type in chat and maybe I'll see it, maybe I'll not. You can just jump right into the voice chat. All right, let us continue forward. So our goal today is at least to cover 11 and 12 in its entirety, maybe moving into 13, depending on how everything moves forward. And then we're going to finish off with the most fun of the items, 14 here: network security, exploits, all right, viruses, all of the cool fun stuff. We're going to talk about them. We're going to talk about how they work and how you would go about making them, and of course how you would go about protecting against them. All right, let's see here. We're going to talk about SCADA today. Now, SCADA is near and dear to every country. Every country will have a SCADA platform. SCADA is what runs the infrastructure of your country. So if we look this up, the big thing on the test is just knowing that this is the control systems for running your country's, what do you call it? I'm forgetting the word right now. But it's what runs your country. So your power facilities, water facilities, dams, etc. Anything that ecosystem, anything that has to do with infrastructure. It's for everything running your infrastructure in your country. That is a part of SCADA. So this would be your power plants, nuclear plants, your water, like I said, dams. I'm probably missing some stuff here. But anything that's important to everyone's everyday life so you can go about and living how you normally live, this is extremely important to it. All right? You can get into SCADA if you apply for various government jobs. These are extremely, extremely important areas of work. And a lot of times, their systems are very, very outdated. The thing that keeps them most protected is they're usually air-gapped. What does air gap means? They're usually completely disconnected from the internet. That way, there's no way to hack them because there's no way to physically get into their networks unless you are near and dear to those networks. If you're actually like plugged into them somehow. That's the biggest way they keep security, which is a way to keep security, but that's not a good way to keep security if you want to stay secure. The biggest thing would be the Stuxnet. So let's go ahead and look at Stuxnet. I can't remember how to spell this. There we go. Stuxnet, which was an exploit that goes against SCADA, all right? Particularly the nuclear program in Iran. So this was a virus that needed to get into this air-gapped environment because they could not exploit it, whoever it was, because there's just alleged individuals on here, but they couldn't get into there because it was a air-gapped environment. A lot of SCADAs are air-gapped. So what do? They infected a USB drive, and the USB drive got plugged into the SCADA system and destroyed it all. All right. So just because you're air-gapped does not mean you don't need good security. You should have good security no matter what. All right. Any questions on SCADA? Again, there's nothing too special per se about SCADA. SCADA could be Windows computers, Linux computers, things you're very familiar with. The big thing is they are meant for running infrastructure that powers your everyday life, and they're typically air-gapped. All right, let's move on to VLANs. VLANs are very important. You've heard of LANs, local area networks, all right? You can also make virtual ones. I know, it's super cool. So where's my prop? Usually this is something built in to most switches that you can buy. Some routers may also be able to hook into your VLAN. But VLANs are super, super cool things you can do because you can effectively act. Let me pull up good old Paint. So we said here before, I'm going to make this really, really big this time. And we have our router right here. It should look very familiar. And then in here is your LAN. All right. But what if you want to make your network even more secure? Let's say this is a business, for example, and your business has a HR department and an engineering department. All right. It has a HR department and an engineering department. To add additional security, you may want to utilize VLANs to separate those logically, which means that when they're on the network, they can't actually interact with each other at all. All right, which is super awesome because if the HR department gets hacked, it means that they can't very easily. It is possible, but don't worry about it right now. It's pretty much impossible for them to get to the engineering department because they are logically separated. So how does this look? you'll have something like, let's say, a switch. So I'm going to put an S right here for a switch, and you program it out on the switch. So now you'll have basically little tiny LANs inside of these LANs. And let's say this one is going to be HR, and this is going to be engineering. Engineering. There we go. And computers can be connected to each one of these. And the biggest pro, again, is that they just can't really talk to each other. Because, let me see, VLAN. Oh, man. I know you guys don't get sick and tired of these drawings. Look at how awesome they are. And let's go back here and connect them up to the switch. So they're separated because if someone at the HR department wanted to directly interface with an engineering department computer, they cannot. The switch will not permit them to do it because the switch will only allow traffic within the same VLAN to talk to each other unless explicitly allowed to interact with other ones. So by default, they isolate people into their own networks, but it's virtualized because it's not really maintained by, let's say, your router or the same systems that generate a normal typical LAN. It's all virtual. If you're using something like Docker, which we've talked about before, Docker does the same thing. Every time you spin up a Docker container, it's going to run these containers in a new VLAN. It's going to isolate them to their own little network that it makes on your computer, and they can only talk to other containers in its network. And we can check this out if we go open it in a terminal, and if we do if config, which I don't even think will, oh, it does work. So if we look here, we can see that its IP address, which is probably really, really small for you guys, is 172.17.0.5, which is different from my IP address on my computer, which is a 198.168 based IP address. So we have completely different IP addresses because, again, this is in its own little VLAN network, all right? So they're completely separated. So if you, and this is the powerful thing about containers and why we recommend people to get our advanced comp sci cert, because it gives you an edge up on things that companies use everywhere, including Docker, and it makes you even more valuable. But this is why containers are used to run everything that you pretty much interact with on the web, because these are little isolated things. So if a hacker comes in and hacked this Docker container, guess what? They're stuck. They're stuck in this VLAN, they're stuck in this ecosystem. They don't actually have access per se to my computer. They're isolated in this container. So that is VLANs. Any questions on VLANs? So again, virtual local area network. And the big thing is for logically separating networks within a network. It's like Inception, just having networks and networks and networks and networks. And there's no limit to how in depth you can go. So for example, if I pull up this, you could have another VLAN in here that has another VLAN in here that has another VLAN, and you can basically do anything you want. You can stack them vertically on top of each other or off on the side. It's, again, virtual. It's all done through software. It's all just made up to help isolate different departments or whatever logically. All right. Any questions on that? Is there any prettier images here? Not really. So we'll just call it good on that. All right. VPNs. Oh, VPNs. VPNs are great if you use them correctly. If you're not using them correctly, which most people are, you're getting scammed. Usually, you know if you're getting scammed if you're having to pay for it so you can watch Netflix somewhere else. VPNs are virtual private networks. They also build upon VLANs. They are awesome. God, I don't want all of these Stupid ads. They're awesome for remote employees because they allow you to get access to local boxes on a network that you're not actually physically connected to. So again, we've talked about it before, but let's go from the bottom. Start from the bottom and go through it. You're taking a trip, or maybe you're remote working. All right, and you live over in, I don't know, let's say you live in Singapore. All right, I'm not gonna spell it all out, but you are now over in the country Singapore. But you have a job here in the US of A. Let's say your job is in the middle of nowhere, Nebraska, all right? Which is a state in the US for those who aren't familiar. So you need to get access to some of the dev resources they may have in their system. So let's go and draw here. Here's the business in Nebraska that you belong to. Let's call it Neb Inc. All right. You work for this company, Neb Inc. Neb Inc. is super awesome. They have a entire warehouse full of computers, resources, machine learning servers that are meant for all the developers to utilize. So let's go ahead and draw some big old server racks. So these are big old server rack computers that you can connect to. Only problem is they're all within the LAN of this network. They don't want to publicly expose this stuff because they don't want normal Joe to be able to connect to their servers. They only want their employees who are physically there to get access to these devices, to these computers. All right? So what's the workaround here? They can't just publicly expose it because now that's a security threat. If the servers are publicly out there, they could be hacked. So the workaround is using a VPN. So if we draw the little router right here, that's a little messed up router. Let me draw, not right there. I'll draw the router right here. We'll draw the router right here, all right? So what's going to happen is you are going to connect to the router and then go to the VPN server, VPN. And you'll authenticate with this server. If it says, hey, you're legit, you're good, what the VPN will do is it will emulate as if you were physically there. Even though you're all the way in Singapore, the other side of the earth, it will emulate like you are in that office space. It will look like to a normal person looking at the network traffic that you are physically in the office. And when you are emulated and physically there, you can access these because now you are a part of the same LAN. It gives you access to all the resources on the same LAN. So anything with a private address like 198.168.0. Let's say 15. Let's say this is this server's IP address. This is a private IP. All right. This is only, sorry, 192, not 198. 192. This is a private IP address, which is only accessible within this LAN. But when you use a VPN, it gives you access and emulates as if you are here physically, and now you can access, using these local IP addresses, the services that you want to connect to. Any questions on that? The additional thing that VPNs do, and this is only to the VPN server. So this connection here from you to the VPN server, typically traffic is already encrypted. It's going to also encrypt your traffic doubly, all right? Depending on what you're doing, it will just be singular or doubly encrypted. And why is this? This is done because you don't want people to know what the internal IP addresses of your servers are, what the structure of your internal network is. So the traffic is encrypted to hide these IP addresses. Your IP here and the IP you're connecting to, the address that is, the IP addresses are still public. everyone can see that you're connecting to this VPN. Everyone can see that you're sending traffic. Everyone can even see the traffic. But the traffic is encrypted to hide your local servers, so people can't figure out what the internal structure is. Because it would be really bad if hackers could see, let's say, Google employees that were VPNing into Google to do their work as while they were remote. It would be bad if hackers could just sit there and sniff and see all of the internal IP addresses and make a map of how Google runs its internal operations. That's a lot of valuable information. Any questions on that? So when you use a VPN service, can I click on this? When you use a actual VPN service, they are scamming you because you're not using it how you're supposed to. You're just using it as a proxy server. So going into NordVPN realm, because I just was working on some video stuff for this, so it's very much at the top of my mind right now. Here is you. Again, you will go across the normal internet where all ISPs can see you. Here's the VPN. Spelled that weird. Oh no, I did spell that wrong. VPN. This is you from Singapore, from Singapore or wherever you are, connecting to this VPN server. Then you going out to, I don't know, Netflix. Because this is how they advertise their stuff. This is a complete waste of your money. Do not do this. All of your traffic here is not private. It's as private as if you were going to connect to Netflix. It's not any more private. That's what I should say. Your traffic here is the exact same. Everyone can see that you're going to the VPN server. All of the traffic from hundreds of people are now condensed to a single VPN server, and you can still monitor where everyone is going. Also, you're not fooling Netflix. Netflix is just building a catalog of known associated IP addresses with you. They've seen your home address. They've seen all the VPN addresses you've used. You're not fooling anyone. You're already logged into their services. You're not hiding from advertisers. They already see where you're going. You're already logged in as a user, and you have your user session tokens already on your computer. You're not hiding. You're not fooling anyone. You're just being lied to by VPN providers. This is not what a VPN is made for. A VPN is made for you accessing resources here within the internal network securely and talking back here. All right? It's this part that you get the benefit from. All right? Anything extra is not secure. It's the exact same as if you were to communicate directly to Netflix. Any questions on that? Also, because it's at the top of my mind and I'm irritated, do not fall for this. Proton VPN, for example, boasts that they're Swiss based. For some reason, that's supposed to be better than based anywhere else. I don't know why. But they say here, I guess this is the reasoning, which is also just bullshit. They say their headquarters in Switzerland, which has some of the world's strongest privacy laws. Cool. You know who else has some of the world's strongest privacy laws? The US, Canada, the UK, Australia. Most of the European Union nations all have some of the strongest privacy laws in the world. Guess what? It only matters if you're a citizen of that country. They don't care, and their privacy laws do not affect you if you are not a citizen of the country. So if you are routing your traffic through a VPN provider to an Asian country like China, guess what? They don't give a fuck about you. You're not a citizen. They barely care about their citizens, but you're not one of their citizens, so they will spy on everything you do. Additionally, all these other countries will, because you are not protected by their laws. All right? The rest of this is just some more things that don't matter. They're stating that Switzerland is outside of the EU and the US. US's jurisdiction. No shit. The sky is blue too. Like, yeah, like this is just them stating things to try to sell you on it, to make it seem like it is more than it is, but it's not. It's not how you use a VPN. It's not what a VPN is used for. You're just spending your money for no reason. Additionally, the biggest thing is you're actually making yourself more exploitable with these services. Why? Because you're extra vulnerable to the man-in-the-middle attack by multiple vectors. What does that mean? Let's show you. Actually, no, even better, Google man in the middle. Man in the middle. It should look very similar to the diagram I gave with VPNs. Look at that. Does a VPN connection look pretty similar to that? It's because it is. You are voluntarily man-in-the-middling yourself, which means that you are willingly sending all your data to these VPN providers. You're not making yourself more secure. You are just adding another person to the list who can look at all of your data. Except better yet, you're consolidating it to one singular point. All right? And then you're sending your traffic off forward. They can snoop, they can look, they can log. A lot of them boast no log policies. They are lying. If you look at the verbiage they use, and some of them even tout they have audits, like, what do you call it? Proton has a audit that you can look at. It's very sus. If you look at that audit, you will see they use very specific language. That specific language is Proton VPN does not log data on their VPN servers. There are more than VPN servers on a network. There are more than just VPN servers that can log your data. They are oddly specific in specifying it's the VPN servers that aren't doing anything to you, but they can have more. Like, you don't have to, there's not just one computer you could be potentially hitting. There's potentially lots of them. Additionally, if you are a government organization, this is awesome for you because VPNs are usually ways that criminals think they can get away with crimes. So most countries will be like, oh, we need a justification for search and seizure. Hey, guess what? Let's plant a wiretap with the VPN providers, or let's work with the VPN providers because our justification is crime, because crimes happen on VPN providers. That is a known thing. So now every person in the world that is connecting, they're all funneling their traffic to a VPN provider. All right. Now, inside of this VPN, or inside of the network that you're connecting to, it doesn't just have to be a VPN server there. You don't have to have just one thing. You can lay things in line. So people could be connecting to a router, which connects to a log server, which then connects to the VPN server, which connects to maybe more log servers or whatever they want to do, which then connects you to the outside world. They're only guaranteeing you security on this thing. So governments can then plant themselves inside of here and see everything from all of these people that are going on at all times. Or if the governments want to be super slick, they'll go right outside to this section of the wire outside of the VPN and just tap into the line and see everything. You are consolidating everything to one single point. It doesn't make any sense. Don't do it. They're all liars. It's aggravating. All right, moving on. Any questions there? Let me get some of my water. All right, cloud providers, cloud computing. If you have questions, go ahead and just ask them in the chat. We're going to go ahead and move forward. All right, so cloud computing, cloud providers, that's the coolest, newest, hip word out there, all right? It was coined very recently, and it's just been going viral since then because it's easiest to tell people the internet is a cloud and things just work, and they just exist in the atmosphere, all right? They're just there. They're just in the cloud. It's not what clouds are. Clouds are just a fancy term for server farms. They are just big warehouses full of servers that you can then access. So there are lots of cloud providers out there, like AWS, Azure, Google Cloud, IBM Cloud, and DigitalOcean. These are all various cloud compute providers. There's also Alibaba Cloud. I don't recommend using them, but you can. That is a thing that does exist. So you can go to these sites, like Azure, for example. We use AWS internally. We like AWS. They are very generous with their nonprofit givings. They have given us at least $10,000 or more to run our services on AWS. So we like AWS a lot, but you can use anyone. I recommend AWS because we can help you the most, but also they are the cheapest and the most well developed. Azure comes into second place, but they still have things to work out. If you go here, like for example Azure site, you can spin up virtual machines, aka these are the servers you want. Anytime you want to spin up a server, it's going to be referred to as a virtual machine, because unless you're paying for bare bones hardware, which means is you paying for all the hardware that's existing there, you'll only get a virtual machine, which is an OS that's running along with a bunch of other people's operating systems on the same piece of hardware. You can also do other things like spin up databases. You can spin up things like AKS, which is a Kubernetes thing, which is imagine Docker, but now this will let you spin up 1 million of those Docker containers at the same time. There's a lot. It's used to run the basically world as you know it for most services. If you want quantum computing, you can get access to quantum computing hardware from these cloud providers. There's lots of stuff that they give you that's available. If you want access to their machine learning software, you can get access to it. If you like OpenAI, because they keep going viral over and over again, you can get access to their services here. You can also go to OpenAI site directly, but Microsoft has a deal with them. So cloud providers are a way for you. The biggest benefit is because back in the day, if you wanted to have your own website or platform, you would have to run your own hardware. Then hosting came out, so you could get server hosting, but that wasn't a cool enough name, so they branded it as cloud. The best benefit for cloud is most things are charged by the hour. So you can easily and cheaply spin stuff up for a couple hours and then turn it off when you're done, which is super, super awesome. If we look here to, let's say, products, their virtual machines, and click on pricing, please don't make me go through a whole dance just to get the pricing stuff. Come on. Okay, I get why they're doing this, but all right, we're going to go to AWS EC2. So EC2 is the same thing as virtual machines on Azure. So if we go to pricing here, you can just see live what their pricing is, and this is based off of region. So you can choose to have a server in Ohio, North Virginia, North Carolina, Oregon, Canada. You can do a server in Africa, plenty of places in Asia or Europe, Middle East, in Southern America. You can literally choose and support and have a local server wherever in the world you want. It gives you the power to have global reach, which is another benefit for cloud providers. But again, it goes by the hour. So if we look here, to run this server right here, it's going to be 2 cents for an hour. And if we change this, you'll see they have lots of different servers. This one is 0.4 of a penny every hour. So pretty cheap, pretty cheap indeed. It makes it very accessible for most people to spin up servers and mess with stuff. Additionally, they have things called serverless, which allows you to basically run servers where you don't pay any money at all unless someone is accessing that resource, which is a great alternative for people in third world countries, which most of them aren't trained on which is a shame because they're utilizing crappy hosting software and building a lot of stuff from the ground up, which is a lot of extra work, effort, and you add in potentially a lot of vulnerabilities. When instead they could utilize stuff like serverless. So for example, AWS has their serverless stuff called Lambda. If I can get to it, there we go. Which is super awesome. And if we look into the pricing here, you'll see that it's going to be this much for every gigabyte second. Or here we go. It's this much for every millisecond of compute time. So it's very, very cheap. All right. If you write a basic Python script and run it, it's usually going to take 1 to 3 milliseconds to execute as a Lambda. So you're paying, every time you click the run button, you're paying this much. So again, very, very cheap. It's great for people. It should be more widely adopted in third world countries for people where your currency is not as strong as the US dollar, but also more importantly, you get paid like $500 a month. That's not enough to really run a server, but you can mess around with these Lambdas and get full quality cloud compute. All right, let us move on. There are several different types of clouds. There's public, private, community, and hybrid clouds. So let's look at what the definition of a public cloud is. So public cloud is an IT model where on-demand computing services and infrastructure are managed by a third-party provider and shared with multiple organizations using a public internet. All right, this is going to be like your AWS. All right, they are public. You can utilize them and get access to their infrastructure. Here's a picture right here. IBM, Google, Amazon, VMware, all the people that we listed are going to be public cloud because anyone can publicly get access and use their resources. Let's go on to the next one, which is going to be your private cloud. All right, this is going to be cloud resources that are private. All right, private cloud is a computing cloud environment dedicated to a single customer. This could also be what do you call it? This is going to be for like internal usage only. Most importantly, it would be things like the government. So the US just won, what do you call it? The US just won, or sorry, the US just had the, what's the contract called? I forget what the contract is, but Azure and Amazon, and was there a third person? I can't remember. They got hired to run private cloud infrastructure, which means that they're going to be spinning up what they have publicly available, but only for access within a company. So this is just for access within the same company. There is community cloud, which a community cloud is going to be a collaborative effort in which infrastructure is shared between several orgs from specific communities. All right, so this could be thought of as what do you call it? Blockchain check is most close to it. I don't know if this one is a scam or not. Do not buy it. All right, I'm just bringing it up as an example. The cloud internet cloud token. Is that what it's called? Oh, here we go. Internet computer. There's this thing called the internet computer token that you can get, and their whole niche is they're pretty much a community network where individuals, not really individuals, they're catered just to cloud providers like AWS, Azure, so forth, but effectively they're stitching together all of their cloud resources to make one shared community cloud resource. So this is probably the best example I have of a community one. They're not too common. And then there's hybrid, which is very common. AWS is technically a hybrid because it has private and it has public, and hybrid is just having both of them. All right, so you can see this when you go into AWS, where is our pricing again? AWS EC2. You could see that they are hybrid, that they have both a public and a private cloud when you went to the pricing here. Because when you go to the pricing, you can see that there are pricing options. When you look at regions, you can spin up your server. There are options in here to do it on GovCloud EU East and GovCloud EU West. So these are going to be private and only for government usage. But they're available here on the public internet, and then you can get access to them. Any questions on that? We are steamrolling through these things. If you guys do have questions, please ask. So, back in the day, when you wanted to make software, a website, a game server, whatever, you would pretty much have to start from nothing and build it all up from scratch and then release it. It was a lot of work, a lot of time. You have to just basically spend most of the time building the foundation over and over again, and then putting stuff on top of that, which is time consuming. With cloud, they now have these things called AAS, all right? AAS, and there's usually a letter put before it, and it stands for as a service. So you can have software as a service, a platform as a service, and infrastructure as a service. What does this mean? Well, as a service means it's an internet service. So just like Facebook provides you a service, and Google provides you a service, AWS and these cloud providers provide you a service. Now, when you use Google and Facebook, those would be qualified as software as a service, because you're accessing, you might not think of a website as software, but it is software, and you're accessing that software as a service. So we go ahead and Google this, and let me see if there's any pictures and a list of other stuff. Not really. So software as a service is pretty much everything you know as the internet. So me going onto Google and searching, that is using their search software as a service. Me going and looking at images is using their image software as a service. So this is something, this is just a term that's coined for describing these, and cloud providers also have their own pieces of software that you can use as a service. For example, they might have pre-built machine learning applications that you can use, and those would be software as a service. So it's pretty neat. Now there's platform as a service, which is super awesome also. Let me see if they got some images here. I kind of like, this is actually a not too bad of an image. So your platform as a service is going to be letting you run your own application on some type of hardware. So platform as a service is going to be you basically requesting maybe a VM or some Docker containers, just some type of operating system that you can then run your software on top of. So this picture is kind of okay. If you look in this blue area, this is basically what you're responsible for. So in software as a service, you just access Google. You just do the thing you want. You have access to their application, and they're doing all of the data, the OS, the management of the server, the storage. They're doing it all for you. You just go and Google things. As platform for a service, all you're getting is basically an operating system, right? You're getting an operating system, and it's your responsibility to put an application on it and then run it. So if you're making a web server, you would have to put the web server on there and then run it. And then infrastructure as a service is going to be you getting even more bare bones, where they're going to give you some type of hardware and then allow you to then figure out what you want to do on top of that, which is usually, what type of operating system you want to spin up. So for example, EC2 would be classified as a infrastructure on a service. Sorry, infrastructure as a service. Let me Google infrastructure. Infrastructure as a service. We got some prettier pictures here. No, we'll just stick to this one. I think this is just a less blurry one. So pretty much you get to choose your operating system. So EC2, what we used yesterday, if you guys were here for it, that was using infrastructure as a service. All right. And then you can also, I don't like this one too much because technically you can do networking also on the infrastructure as a service tier. Docker would not be infrastructure as a service. It would be PASS. It would be a platform as a service because Docker runs on top of an operating system, all right? Because we have to have an operating system to run Docker here. Any questions on these? There's just the three that you need to know. Infrastructure is pretty much you starting at the operating system level and you're responsible for choosing an operating system and doing everything from the ground up. Platform for a service is you already have the operating system and you just need to add whatever application you want. And software as a service is everything's already made and ready for you to use. Any questions on that? If not, we're gonna go ahead and take a 3 to 5 minute break, and then we're gonna go over point 13 here. All right. If you guys have questions, please ask them. Please ask them. Please ask them. Please ask them, and I will answer them right after the break. Alrighty, alrighty. We are back. Back. Alright, sweet. Let us continue, shall we? So, before we do, we have a giveaway going on. If you haven't yet, make sure you go over to our site, click on blog, and you'll see our week 4 giveaway. And you can participate. It is free to participate, alright? You just have to do basic things like subscribe to our YouTube channel, our Twitch, so on and so forth. There's a bunch of tasks here, very basic, and then you can participate. If you like what we're doing and you want to help support us, you can go over here. We put the link into the chat already, but I'll do it again. It's usually in the description, but the description on YouTube has not been playing nice with our software at all. So if you go over here, you can donate. All donations are being matched 1-for-1, thanks to a generous anonymous donor of ours, and you can redeem several rewards based off your donation. And we have these benchmarks that we will potentially be hitting depending on how much, depending on how much is donated. So at 6K, we'll be streaming for 24 hours straight. At 10K, I'll be shaving my head here live on stream. And at 20, that's the one we're not going to hit. Shaving my beard. Come on. No one wants that, all right? No one wants to see that. All right. Shall we continue our journey? So next, we're hitting upon the CIA triad. This has no association to the actual CIA. This is a completely different concept. So it's just a concept in networking, but not just networking, in just computer science in general. And it stands for confidentiality, availability, and integrity. All right, these are things that you want in protecting data. All right. So as you're sending data, receiving data, processing data, just various things about data, these are the things that you want, especially for your application. So you want your application and whatever you're doing, this data, to be available at all times. But you want to make sure also that it is confidential, aka it is encrypted, it is secure, and the integrity of it is intact. It's not just someone that's doing a man-in-the-middle attack on you or compromising the data in some way. It's also the original integrity of the data is intact. All right, very super important concept for you guys to know and be aware of when you're making your applications. There's also another concept called information assurance. All right, this one has 4 pillars. Let me see here. Where are my pillars at? There we go. 5 areas. I don't know why they don't have the pillar picture. It builds off of the CIA triad. So you'll see the CIA is in here, but they add some additional stuff like authentication and non-repudiation. So let's go ahead and click here on the NIST article, and they never have just a typical, just good definition right here. So let's go, where's Wikipedia at? All right, so we got our CIA triad, which you can see right here, and some of our additional items. These are the pillars that are important, the 5 pillars that can be on the test, and you can see they're listed here. So authentication refers to the verification of the validity of a transmission, originator, or process within an information system. All right, so it's from someone that is allowed. They're verified and they're allowed to do something. All right, integrity is that it refers to the protection of information from unauthorized alteration. Whatever I tell you gets to you undisturbed. All right, no one's just changing it. It is exactly what I sent you. It's important to have that. Availability. You want your service to be available. You want people to be able to access it. Confidentiality is the essence, the opposite of integrity. Confidentiality is a security measure which protects against who is able to access the data, which is done by shielding who has access to the information. All right? And then there's non-repudiation, which is the integrity of the data to be true to its owner. So there are slight differences between these. So for example, integrity is the message that was sent to you was not altered. That is different than non-repudiation, which is, for a matter of fact, the information that was sent from you was sent by that one person who says they sent to you. It's 100% from that originator. All right, very important distinction, something to be aware of. And this is important for your security of your platform. You need these things in place to secure your applications, to secure your cloud platform. All right, cybersecurity is something you need to be aware of and you need to know about. These things will be harped on more in depth if you ever take classes like NetPlus and SecPlus. All right, those are great classes that I also recommend you taking, but it's not going to help you too much for getting a developer job. Those are more in the cybersecurity IT realm, but they are really great for you as a developer to know about and have, that type of knowledge, and to make sure your applications are compliant. All right. There are tools in cloud platforms like AWS, which Taylor knows the name of. I can't recall them right now, which will help you in analyzing what you're doing and making sure you are sticking to and conforming to these ideologies. All right. Any questions in regards to that? That's pretty much all we had planned for today. Unless you guys want to get into network security, we can start moving and migrating into it. But that's totally up to you guys and how you want to go about. But that is all that we had planned for today to talk about. Any questions, comments, concerns you guys want to keep trekking for, or you're pretty much good with what we've covered today? Now, if you didn't quite get how these get into play, they'll definitely make more sense when we get into this network security part, because it kind of boils down to having things available, but securing your network and making sure, some person isn't able to get into your network. And if they do get into your network, if you do get compromised, you have the proper things in place to log, so that way when investigators come in after the fact, they can then figure out who exactly did what and where, and not like some employee came in and accidentally messed things up. It will all make sense as we move forward through that last section. I see that you guys are pretty much Gucci. Got some catching up to do, and you are okay with today being a bit shorter. Sweet. If that is the consensus, then we are going to call that good, and tomorrow we're going to go about to sneeze. Whew. Tomorrow will be all about network security, and then after that we're going to be done. We're going to be moving on to operating systems, and it's going to be fun. We're going to get lots of practice in various different terminals, right? It's going to be a wild, fun ride, and you're going to learn a lot of stuff, and it's all going to seem like very valuable to you, and it is very valuable, but you'll actually be able to start getting your hands onto stuff. All right, sweet. If there are no other questions, then that is all I got for you guys today. So I will see you guys on the next one.